Hello, everybody. My name is Slater Victoroff, and I'm really excited to be here at this virtual shift, and I'm going to be talking to you about deep learning and intelligent process automation. Um, so a lot of you have probably realized automation has been in the news a lot lately, and people have a lot of very different takes on it, and since we're going to be talking about it, wanted to go through a little of the context. Some people might be familiar with this guy, Andrew Yang, who's a recent U.S. Democratic presidential candidate, making really big waves, at least here in the U.S., by making automation kind of the central thesis of his campaign, saying that automation, and very specifically this upcoming fourth wave, what's being called the fourth industrial revolution, that's a lot of software-based automation, is the central challenge facing, us being kind of the world today. And anyone who's not addressing that is failing their constituents. At the same time, you've got people like Daniel Kahneman who are saying that actually without the promises of automation, global economies may collapse. And this is something that a lot of people might not be familiar with, but there are a lot of economists out there that have basically modeled that with an aging population, we might not be able to keep sort of the growth of global GDPs in line, which could cause to a lot of really, really big issues with sort of debt inversions. And so when you got these really kind of distinct views on automation, right, what I want to do is kind of cut through that a little bit and really show you what's happening, right? I've been working in this space for about 7 years now. It's a pretty new space, so I wanted to share some lessons that we've got from the front lines. So I wanted to start quickly with, why now, right? What about automation has changed so drastically in the last couple of years that has caused this to become sort of a really, really big topic, much more so than it had been until pretty recently. And I want to start by talking about robotic process automation, or RPA. Now, a lot of you have probably heard of RPA previously. This is a really, really big industry. It's kind of exploded recently. A couple of large companies like UiPath, Automation Anywhere, Blue Prism, but kind of countless others. If you're not sort of a finance person, you don't have to worry too much about this chart. All that it's saying is that this is a multi-billion-dollar industry that's growing, upwards of 20% year over year, and is projected to for the next many, many years to come. But what is RPA, if you're not necessarily as familiar with it? This is kind of a quick quote from UiPath, who, as I mentioned previously, is one of the real leaders in this space, one of the largest companies, sort of a recent unicorn. And it's something that is specifically designed to allow sort of non-technical people, right? So this is, if people are familiar with Selenium, it's a kind of similar set of functionality to Selenium, but it's putting that in the hands of a non-technical person and kind of enabling it on the desktop. So to say it another way, right, in RPA, you're going to have sort of a basic set of relatively, robotic processes that you can take, right? You can cut and copy things, you can open up different applications, and what you effectively do is you combine those to put together sort of a larger robotic workflow, right? So for instance, you open up Excel, you copy some values, you put those into, you open up QuickBooks and you put the values in there, right? So that would be an example of something that you might automate with a robotic process. And just some sort of basic terminology, there's sort of a concept of an attended and an unattended. When you've got this full process running, you say you have a bot in production, and you can have an attended bot or an unattended bot. As the name kind of implies, attended is, a person sitting there watching the thing run. It very possibly even might be that the full process isn't automated. So maybe you run one bot, you type some things into an interface, right? You run a second bot, something like that. Unattended, right? It sits in a rack. It just runs. It does its own thing. The vast majority. Sorry, can I switch screens? Oh, yes. Apologies. I had myself on the wrong setting. Hopefully that's a little better, y'all. So you've got this idea of the attended and the unattended bots. The vast majority of all RPA bots today are attended bots. Sorry, it looks like did not. Oh. I see the problem. Sorry about that, everyone. Okay, now Sorry. For some reason, it will not actually switch over in OBS. Sorry, everyone. I'm trying to get the sizing of these two right, but it won't actually switch over. You know, let me, apologies. We're going to do this kind of an exciting, more live way. Okay, all right. So it looks like that actually has been successful. Apologies, everyone, for the technical issues, but now hopefully you can see my slides a little bit bigger. This will be a little bit more easy to follow. Right, so as I was kind of saying, RPA has exploded recently, and for these kinds of simpler automation tasks, it's been really, really successful. However, what this has really given rise to is this even desired kind of further extent of automation, right? Sort of this new field called intelligent process automation. And that's what we really want to talk about today. IPA, and this is kind of a definition of IPA from McKinsey, who is really one of the leaders in this space. It's really the idea of trying to leverage both the existing sort of business process tools, right? And that's things like RPA, as well as primarily AI tools, and using those in combination to kind of tackle repetitive, replicable, and routine tasks that today are kind of done by people largely. And learn to do them potentially with more consistency or better accuracy, but we'll talk a little bit about exactly how those interact long term. So these are a couple of example use cases if you're still kind of struggling to figure out, okay, you know, what is IPA, what is RPA? These are sort of canonical examples, right? Something like contract review, where it's not just about getting a number from Excel and posting in QuickBooks, right? But there's actually some interpretation that has to happen. That's why this is intelligent process automation as opposed to robotic process automation, as you might gather. You have things like invoice processing, corporate inboxes, where you have to route incoming emails, right? Really anything where you've got a relatively simplistic process that today, you know, surprisingly enough, most of these are done entirely manually, right? Someone looks at every incoming email and figures out who has to respond to that. Or for a form, right, someone brings up a PDF of the form, they manually key in the values for each particular piece. And IPA looks to really automate those types of processes. So to kind of recap, right, RPA, you can say things like copy the values into QuickBooks from the Excel sheet, right? You can say, you know, if you've got Salesforce and your Excel sheet and, you know, two other CRMs, you can say, okay, I'm going to enter the information in my RPA application, and then the RPA bot will go and enter that into several applications, right? So those are the kinds of things that's really good at automating. IPA, on the other hand, right, this is anything where you've got some interpretation, some intelligence that's going on in the process, right? So checking the data protections in the contract. You know, you have to read through the contract, you have to parse it, you have to understand what is a data protection, and in a lot of cases actually do some interpretation of that in your model. Or check that all of the documents in a loan approval are in good order, right? So when you look at a loan and when someone applies for a loan and when they get potentially subsequent approval, there's a whole set of documents, and it actually is kind of very related to the anti-money laundering that Weber was actually talking about in the presentation earlier. You have to check that all of the documents kind of agree with each other, right? When someone sends in a pay stub and sends an application that says how much money they're earning and also sends in some ID, right? You have to check that those are actually all for the same person, right? And when you look at a standard loan, right, I mean, there may be dozens of pieces of documentation, and the process of just checking that all of those match, you know, it's slow and it's actually kind of surprisingly error prone. And when we wonder, you know, like, why is IPA so interesting, right? If we look at the kind of successful automation initiatives out there, right? So the entire world, you know, RPA and IPA use cases, who's actually getting into production and who's actually getting sort of a lot of value from these. We see that folks using sort of this IPA strategy, and again, that's kind of really, really heavily ML-based techniques here, and natural language processing in particular for reasons that you'll see in just a second. they're actually twice as successful as kind of more typical automation initiatives. So while IPA is still relatively nascent, right, it's still kind of a new space that's not nearly the size of RPA in terms of the full automation landscape. It's growing very, very quickly, and especially kind of top organizations that have been a lot more successful in automation are investing in this kind of disproportionately. McKinsey calls, IPA specifically, right, and sort of this broader push, the automation imperative, right? And for folks that have been spending a lot of time in enterprise software, certainly in the last couple of years, you've seen automation centers of excellence show up, across the entire Fortune 500, right? And truly, this has gone through sort of a really, really categoric sea shift. But I think what people, what's not necessarily as obvious is that there is this disproportionate focus on sort of these machine learning driven process automations. So now we'll talk a little bit about kind of the lessons learned from the field, right? Practically what's the reality of this space, right? What's hype and what's kind of actually going on. So the first thing that I want to talk about is the modeling of this, right? And when we talk about intelligently automating a process, like I said, these are typically deep learning models. But when you look at what is even, a pretty simple problem here, right? Let's say I want to kind of extract this $5 number, right? That's a really kind of classic IPA use case. The problem is that I've got all sorts of visual structure here, right? I have to understand that this basic, right, this 504 doesn't just apply to that, but there's also this header for basic, right? I have to understand not just that this read order, right, I have to go December 28th, 2019. I can't just read this through like a line, right? That would be December 28th, December 29th. Earnings per share 2019, 2018. But that issue of read order is actually really, really tough. And you can kind of recognize that it's very hard for a computer to automatically figure that out. And then we realize that even if I get that block appropriately, that's not even the whole issue, because I also have to understand that there's this header relationship, right? 3 months ended to this date. And again, believe it or not, this is a pretty simple example. Things get a lot more complex than this, but we start to recognize really quickly that a lot of these IPA processes don't fit really neatly into the traditional set of problems, right? This is not really a classification task. It's sort of a named entity recognition task. The issue is that when you think about traditional modeling approaches, right, they're really heavily stovepiped by what kind of data you're dealing with. Everyone's familiar with sort of the classic computer vision and image techniques, ImageNet being that classic data set, AlexNet, BGG, ResNet. Text, that's been a lot more common lately. For some reason, all text network architectures nowadays are named after Muppets. So Elmo, Bert, and Ernie are legitimately actually some of the most popular and sort of best performing NLP models in the past several years. Audio, there hasn't been quite as much, but there is WaveNet, and the point is still primarily just that all of these approaches are completely separate. And we think about something like this. This is clearly not just a text problem, right? This is clearly not just an image problem. But what's fundamentally difficult about this is that you have to somehow figure out how to combine those two streams of data. There aren't really good data sets for this, and from a machine learning perspective, it's a really challenging problem. In practice, what people end up doing is actually just focusing on text, right? So the idea is rather than actually trying to model the complex dynamics here, that's kind of still a very active area of research. It's something, if you want to learn more about, look into sort of rich embeddings and model surgery, and that's really a field focused largely on this sort of problem. But nowadays, what you do functionally is you just run everything through BERT, right? And this is not really news, I think, for a lot of people in the NLP space. But what you do is you take an input like this, you run it through some sort of traditional off-the-shelf OCR, and then you model the whole sort of extraction task as just a pure, kind of a custom named entity recognition. So, it is still challenging, right? There's absolutely still more work to be done here. The problem is that, if you try to really tackle this problem head on, you'll never end up making progress. It's too difficult. It's too difficult a problem. The second piece is when we actually talk about automation, automation is largely metaphorical. When you look in practice and getting these into production, most things actually are going to fall into what I call augmentation. I'm just going to explain what I mean by augmentation, acceleration, and true automation, which is actually quite rare. So the idea of augmentation is that a human is still looking at every document, is still processing every document. But what happens is that you have sort of a computer assistant whose job it is to look at the document and provide information to the human that will allow them to do their job more quickly. Sometimes there's closed loops, so that human's feedback gets fed back into the model. This is distinct from acceleration, where the idea is a computer will selectively decide to sort of bring a human into the process if it's not able to automatically, recognize that it's extracted the right thing, or if the confidence is not quite sufficient. And then it'll actually get executed. And true automation, right, this is where you have your documents, they're hitting a computer, right, they're actually, your model is extracting whatever values it needs to, it hits the world, and there's no human intervention whatsoever. This is rare for a couple of reasons, but one of the really big issues actually is that you are not legally allowed to have an architecture like this for GDPR reasons. I'll just go through this super quickly. There's a lot of debate about exactly what people mean by explainability and what GDPR means by explainability. The most important clarification they've given recently is in Recital 71 that says fundamentally explainability can only be met by comprehensive testing, and any human who is subjected to an automated decision must be able to opt out. So in practice, what you need to be able to do is actually, while this might happen in an automated way, anyone who is subject to that, so if someone gets their loan rejected, right, by an automated algorithm, you still fundamentally need a person in the flow such that when that's rejected, a person can manually examine it. So even in a full automation scenario, there are still people involved. And so when I say automation is largely metaphorical, that's really what I mean. The final and maybe the most important lesson that I want to touch on is that the existing process is often assumed to be really, really good. But as we've kind of realized, these are heavily biased processes, right? They're ones that for some reason, when you want to automate a solution, it's very important that you measure it. But for whatever reason, when it comes to only, a pure human solution, no one really does decide to measure it. And the thing that people don't realize is that when we think about these processes, we think about a loan approval, we think about reading the date of birth off of a driver's license, right? We would never make a mistake, right? We're sort of this very professional, right? We think of ourselves at our best when we've just had a cup of coffee. In practice, though, what's happening is that the people who are actually doing these processes, right, are doing them for 6, 8, 10 hours straight, day after day, and mistakes accumulate, right? And that's just because humans aren't meant to do that kind of routine, repetitive work for such long periods of time. I actually don't quite have time for this analogy. I'll skip past it just to say that these errors show up in production constantly, and many people are surprised to learn that they may have sort of as large as 10% of their entire body of loans might actually have issues according to their own internal process, right? Someone may have forgotten their identification, or there just might be fundamentally inconsistent documentation. They don't even know because these kinds of mistakes are so common. So just in conclusion, to kind of wrap up, right, intelligent process automation, it's a super interesting space, and it's not something that you should really think of as being far off anymore. These applications are going into production every day. The fourth industrial revolution is well underway. Despite the fact that deep learning is moving so quickly and the models here and sort of the approaches have gotten drastically better in the last couple of years, it's still a very, very nascent space, right? It's still very new. It's not something that has sort of a very comprehensive set of best practices. And even though people talk about intelligent process automation really readily, as I said before, automation is extremely rare, right? It's certainly less than 5% of all use cases out there are true automation for very, very good reason. And finally, humans and computers cooperate much better than they compete. When you look at the models of this that are actually really being successful, right? It's not full automation, right? It's not models reaching human performance and then you don't have people do it anymore, right? Just like the original Industrial Revolution, that analogy is becoming a lot more apt, right? This is humans and computers working together to complete the process much more effectively in a more consistent, less biased way. And that's my presentation, and I think we've got a couple of questions.